All right, guys, again, if you have not done the one that doesn't deal with transformations just as a function, please go back and do that 4, 5, 6 times. When you can do it without your notes, you can come and do this. All right, so because I'm not going to explain it as detailed. So let's start off with our graph cosine. So again, sine goes through 0, cosine starts at 1. So this is our graph. What are we going to do? Outside is y and regular. So what does that mean? Whatever I think is going to happen in the y direction is going to happen, which is move up 1. You'll notice that there are 3 dots. This dot right here does vertical stretches and horizontal shrinks and flips, all of that. But the dot in the middle is the one that moves graphs. So you see, I can move this graph wherever. So again, you got to kind of keep track of those dots. This one is the one that moves. This can stretch, flip, shrink, that kind of stuff. So again, if I want to just move it up 1, I go to the middle one and I move it from 0 and it goes up 1. That's it. All right. Again, we're going to start with sine. So sine is the one that starts in 0. And again, what am I doing to it? Outside is y and regular. So this is down 1. If you are not understanding what I'm saying, because you need to go back and do regular transformations before you can do sine and cosine. So I'm only focusing on sine and cosine in this video. All right. So this is going down 1 because it's y and regular. All right, so we're starting off with a cosine graph. So this is a cosine graph, starts off at 1. And what are we doing inside? So x is, inside is x and opposite of what you think. So this you would think means right pi, but it really means left pi. So what that means is each of these points is going to move to the left pi. And how far is pi? So there are a couple of ways that you can do this. I can see that this point right here is a pi, right? So it needs to move all the way to 0. So I'm moving left because it's opposite. So if I drag this point, as long as I keep track of the other point right here that comes to 0, I'm fine. The other way that I could do this is I could count it with boxes. So pi is how many boxes? 1, 2, 3, 4, 5, 6 boxes makes 1 pi. So if I move this 6 boxes to the left, I should be good. That's 3. And another 3, that's 6. So you see, I end up at the exact same point. So you can look at these, or you can look at the boxes depending on what you're looking at. All right, so we got a couple of transformations. Again, doesn't matter what you start with. I'm going to start with the inside. Okay, so inside is x and opposite. I would think go left, but it's really go right, pi over 2. So how much is pi over 2? Pi over 2 is 3 boxes. So let's start off with our graph, which is cosine, starts at 1. And I need to move it right 3 boxes, and I know that because it's 1, 2, 3. 3 boxes. So I need to move right 1, 2, 3 boxes. So every point has shifted right 3 boxes. Then what does outside do? It's y and whatever you think, which means it's go up 1. So I can move, if I try to move this point up 1, look, what does it do? It stretches. So my movement has to be this middle. So it starts at 0 and I go up 1, I'm going to end up at 1. Okay, you just kind of get used to the points. All right, so again, inside is x and opposite. So I would think go left, but I'm really going right, pi over 4. So let me see, pi over 4 is how many boxes? Okay, I don't have a pi over 4. So now kind of think through, what is a pi over 4? So pi over 4 is 1/4, right? So 1/4 of pi. So here's pi. This is half of pi. So half of that will be 1/4. So 1/4 is 1.5 boxes. All right, so let's go ahead and start off with sine. And we're moving this to the right, right? So this is my middle one. 1.5 boxes. So this is right here. That's going to be 1.5. Half, okay, we're moving it half of a half, right? Like 1/4, right? So if this was $1, this is 50 cents, and this is 1/4. So you're moving it to the right 1/4. What does a plus 1 do? So again, it's outside, it's y and regular, so it moves it up. So I'm gonna, the one in the middle is a moving. I'm gonna move from 0 up to 1. All right, so again, all this is just multiple transformations in one, and you can start in any order that you want. I'm gonna do my movements first because I think I wanna do that first. But again, you can start anywhere. So sine starts in the 0, 0, and I'm gonna do my movements first because that's what we've been doing recently. So this is going to be, you would think goes left, but it's x and opposite, so this really goes right. So it goes right 3 pi. So what do I do? Because if I take this movement one, right, this is the one that moves, it'll only go 2 pi. So I need it to go another whole pi part. But let's think about this unit circle for just a quick second, okay? So remember, when you have this whole circle, right, I'm gonna make this is 0. This is what? Pi over 2, right? This right here is pi. Then we go to 3 pi over 2. All right, then we go to what? 2 pi. So if I'm right here and I go 2 pi, I end up at the exact same spot. So really what I can do is I can take 2 pi away from 3 pi, which will just leave me with pi, because if I move 2 pi, I'm at the exact same spot. So if I stop back off with sine, instead of moving 3 pi, because I'm way off the graph, right? I know that if I move 2 pi, my wave is going to look exactly the same. So all I have to do is move the extra 1 pi. So if I'm at 0 and I'm moving right 1 pi. So again, I'm going to say that again. We know that a coterminal angle is the angle in the same position, just going around the circle several times, right? So 2 pi is a coterminal angle to 0. So if I move 2 pi, I'm still at the exact same spot. I just went around the circle 1 time. So I'm at the same spot, which means I just need to move pi more. Okay, so that's just what I mean by that. All right, so that's that. Then we're going to do, let's reflect it first. So again, I'm going to jump around, but it doesn't matter the order that you do this. So I'm going to do the movement first. Let me go do this negative. So negatives are opposite no matter where they are. Whether they're inside or outside, they are opposite. So outside would usually be y, so opposite would be x. So this negative is a flip over the x-axis. So this is the x-axis right here. Is it not letting me write? This is the x-axis right here. And we're going to take this point. Oh, wait, it's moving it. Oh, sorry. Put it back, put it back. We're going to take that point and flip it, bring it from there to this side. Okay, so it's not letting me write on that anymore. Why not? Nope, it's not letting me write on the graph, and that's fine. So you're going to take this point and bring it to this side, right? So you're going to flip it, all right? So if you imagine that you have a book, and this is the x-axis, so the book is horizontal, like so, right? And you're going to, so this is your x-axis, your spine, all right? You're going to flip it. All right, so whatever is on the top is going to come to the bottom, and whatever is on the bottom is going to come to the top. All right, so when you flip that, all I'm going to do is take one of these points and move it to the bottom. So you see the other point automatically went to the top. So now I flipped it. Now I got to do this times 2. All right, so what does times 2 mean? So times 2 is just going to be outside, which is y, and regular, so it's what you think it is. So now I'm going to stretch it, right, by 2, double it. So if I'm at 1, if I stretch this, it goes to 2. And notice this other one that was at -1 also went to -2. Stretch by 2. All right, so I did that, this. The last thing I need to do is -2. Well, what's that? That's inside or outside? It's outside, and it's going to be y and what you think. So what do you think -2 is going to do? It's going to bring the whole graph down by 2. So let me find the middle point, because that's the one that moves it. All right, so at this point right here, and I'm going to start off at, I'll start off at 0, and I'm going to move down 2. And hopefully I didn't move it because I kind of lost track. So let's see. If I'm wrong, that's fine. I don't mind doing it again. All right, perfect. All right, so again, it doesn't matter what order. Let me try going in exactly the same order from left to right. But again, it doesn't matter. So I'll start off with a negative. So start off with cosine. A negative outside. So it's negatives are opposite whether you're inside or outside, right? So opposite. All right, outside is y, so it's really flip over x. So here's my x right here, which means this point up here comes down here. I flipped it over the x-axis. All right, let's go ahead to the next one. This is times 3. Outside, right, it was y and regular. Times 3 is going to do what to it? If I multiply by 3, I'm going to stretch it in what direction? Vertically. That means wherever, so let me find things I can stretch. I like to stay positive. All right, so I'm gonna go with a positive. If it's at 1 and I stretch it vertically by 3, it's 3 times as big. I just multiply 1 by 3 and boom, 1 by 3. All right, so that's that. Now I'm inside here. So again, x and opposite. So instead of going left, I'm gonna go right, pi over 2. So now keep track of where we are. I'm going to move every point, right, to the right, pi over 2, which is 1, 2, 3 boxes. The only thing that can move, this cannot move, because what does that do? That does what? A shrink, right? The only one that can move is the middle. So I take the middle, and I know pi over 2 is 3 boxes, because 0 to pi over 2 is 3 boxes. From pi over 2 to pi is 3 boxes. Okay, so basically half of pi is 3 boxes, no matter what I go to. So I'm going to take this and move it to the right, 1, 2, 3 boxes, right? So if you were already at 90 degrees and I wanted to move you right another 90 degrees, you'd be at 180 degrees. That's what that means. in degrees. All right, and then finally, the last thing is take that, and we're going to be outside y and regular, which means take that and move it up 1. So again, to move, you need to find the middle one. This is the middle. It's at 0, so I just need to move this whole graph up 1. All right, so these transformations, let's just do left to right. It's just multiple ones in one. All right, so let's do another one. Start off with sine. That's the one in the middle. All right, multiplication outside. So y and regular stretch by 2 in the y direction. So take the stretch ones, which is anything on the outside. Stretch it by 2. Okay, now we're inside. Okay, so this one is a fraction of 1/2. Inside is x and opposite. So 1/2 you would think should shrink it, but because it's x and opposite, it should stretch it. So what's opposite of half? So if I take $1 and I take half of $1, I'm at 50 cents. But what's the opposite of doing that? What's the opposite of taking half? Opposite of taking half is double. The other way you can think of it is just the reciprocal. All right, so if you have a fraction, let's see if I can write. If you have a fraction as a half, what's the reciprocal of that? It's 2/1. That's what the opposite's going to be. So when you have fractions that look like this, again, the opposite of that will be take the reciprocal, which is flip the fraction, which would be this. Okay, so depending on what the fraction is, hopefully I get one of these so I can do that. You just take the reciprocal. So again, instead of taking half, the reciprocal is double, which means this is going to get wider like this, right? Now, if it is cosine, be very careful, but sine is okay, all right? Because it's sine, when I get wider like this by pi/2, which is how many boxes? 3. So again, I take one of my points and I move it 3 boxes. You see how it's getting wider, right? So it's getting wider. That works. But if it's cosine, there is something special you have to do with cosine because it does something, and I'll go over that, so make sure you're listening when I do a cosine one. All right, so that's stretched it by 2. And then the last thing is outside y and regular. Oops, I didn't mean to cancel it. Is whatever you think, which is up 2. This is the one that moves. We just move it up. 3. Oops, I almost got that wrong. All right, so we're just following the order. All right, guys, so we finally got a cosine one, which is what I was looking for. So start off with cosine. Outside is y and regular, so this is a vertical stretch by 2. Where you need to be careful is when you get to the inside stretching and shrinking, because when you do this with cosine, unlike the sine graph, you see when I do that, this point moves as well. So I'm just going to put this back, stretch it by 2. All right, so you need to make sure that each of these 3 points gets stretched, right? Because this is a fraction, so you'd think it shrinks, but opposite would be stretched. So it stretches by 2, the reciprocal. So it stretches by 2. So this point in the x direction is at 0. 0 times 2 is still going to be at 0. So this point has to stay right here. When I take pi/2 times 2, this point should move to pi. And this point right here, when I stretch it by 2, it should move from pi to 2 pi, I'm sorry. So watch, when I do this, what happened to the point that was at the 2? It also moved, okay? So again, we have to be careful to make sure that we're doing this correctly. So what I'm going to do is this. I'm going to move this to 0. Okay, then I'm going to stretch it and move it back. Okay, so again, I'm moving that to 0 because when I do this, when I stretch, it's not going to move. So this by 2 is going to stretch to that. Then I'm going to move it back. Okay, so where the 2, right there, where the 2 is the peak. All right, so I should have expected, and again, I'll do this again. I should have expected a peak right here, and then, this should be on pi. Boom. Make sure you're exact. Okay, I should have expected a peak right here, then pi, then 2 pi. And I'll just show you that again. So I'm going to do a vertical stretch back. So again, this pi/2 should be at pi. This bottom should be at 2 pi. So if I do it that way, if I put the bottom at 2 pi, nope, see, that doesn't work, right? Because now the bottom is not at 2 pi. So again, be careful. I think the easiest way to do this is just to move it to 0. So move this to 0 and then move it back to where this is where it's supposed to. So I'm going to move this to 0, stretch it by 2. So this is going to end up to pi, and then move it back to where the peak is at 2. So if I move it back, oops, boom, it's at the peak. So I got the peak, pi, and then the other peak is at 2 pi. So be careful with this one. This is one of the ones you have to be careful with because it doesn't start at 0, 0. You have to do that kind of like little maneuver. Where's submit? Oh, I didn't even finish. I'm sorry. Thank God I couldn't find the submit button because the last part is to -4 is outside. So what am I supposed to do? Down 4. So I'm going to start the one at 0, 0 and move it down to 4. Okay. Oh, There's my submit button. Thank God I didn't find it because I would have been guys. Couple of things that we have to be careful with. Every question we've done so far, if we had a fraction with x or a number with x, we did not have to have a shift. There's something minor that we got to correct if we do have a shift, as well as x is not by itself. So first, we're going to put cosine as always. All right. 1/2 inside means what? Double, right? So everything needs to double. But remember, with cosine, it's a little weird because if I double this, 0 needs to stay at 1. Double this needs to come to pi, and double this needs to come to 2 pi, right? But as soon as I move this to 2 pi, what happened? The one that was at 0 that needed to stay there moved as well. So we have to be careful. What we're going to do is we're going to move this to 0, double it, so this goes to here, right? Then move it back to where 1 is on the top, all right? So that was that special thing with cosine just because of the dots they give us. Now, the other special thing we have to do is this. The period isn't really right pi over 2. It's actually something different because this 1/2 has already affected it. So to get the period to what the period actually is, what we need to do is factor out the numbers that we have inside. So we're going to rewrite this to cosine. And then what can we take out? We have a 1/2 that we can take out that's the greatest common factor. That will leave x minus pi, right? So if you multiply this back in, you get the same thing here. So once you take out the greatest common factor, you find the hidden period. So the hidden period is actually take this graph and move it to the right what? Pi. So this one that's at pi should go to 2 pi. This one that's at 1, 0, 1 should go to pi. And this was obviously going to be off the graph. So the middle one is what moves it. Notice I'm moving it to the right by pi. Okay, I'm going to do a few of these because these are the ones that are going to get you confused. The ones that, again, x is not, I did not mean to do that. X is not equal, x has a coefficient to it as well as there's a shift. So with that, there's going to be a little bit of difference. So again, start with my cosine. All right, times 2 inside is x and opposite. So you think times 2 opposite is divide by 2. So it's going to get shrink, right? So it's going to shrink by 1/2. And again, because this is cosine, this does that weird thing when I try to shrink this by 1/2. So pi by 1/2 is going to go to pi over 2. And look what happens. Oh my God, the whole graph disappeared, right? So I'm put it back. Again, the weird thing with cosine is we're going to move this here to 0. And the reason we move it to 0 is because when we shrink, it shrinks around this point right here. Okay, whereas if I don't move that to 0, anytime I move this, you see how that point stays stagnant? And we don't need that to happen. So I'm going to move it to 0 and I move it back after I shrink it. So shrink it by 1/2. So this you can see is 3 boxes. So this is going to be 1.5 boxes and you can see it shrank, right? By 1/2, move it back to where the 1 is right there. Okay, because you got to kind of play around with it because of how IXL does it for us. So this is shrunk by 1/2. Now, remember this period is not the true period, right? So what we actually have to do is rewrite this with the true period by taking out the greatest common factor. So what's the greatest number that can go into 2 and 4? We can take out 2. So in other words, you really have to just take out whatever is with the x. Whatever is bothering x, take that outside. So you're going to have what's left, x minus, and that's what's 4 pi divided by 2 is going to be 2 pi. So our movement is going to be right 2 pi for this to be correct. That means everything moves 2 pi. And what do we know about 2 pi when we think about that unit circle, right? So this is 0. If I go around the circle and I go all the way around, that's how much? 2 pi. So going around the circle, you end up being where you are. If I do it again, I go all the way around. How much is that? 4 pi. But I'm exactly where I started. So anytime I have to move right or left 2 pi, I know I'm just going to end up exactly where I started because this is that periodic wave that does the same thing over and over again. So I actually do not need to move anything. I can just submit that. Okay, again, I'm loving that once you get, I guess, past a certain number, you're getting these where x is not by itself. Because if x is by itself, then the period is true. But if x is not by itself, this period is not true and you have to adjust accordingly. So I'm, again, going to start off with sine. I'm going to talk about this negative first. What does negative inside do? Negatives are opposite no matter where you think they are. So opposite, it's x and opposite. So I would think flip over x, but I'm really flipping over the y. So I'm going to take the sine and flip it over the y. So it's a pi over 2. I'm going to put it on the other side, negative pi over 2. Then I'm going to deal with this 4. Okay, 4 inside, you would think that it does what? You think that it stretches, but it really shrinks. So just make sure, as I shrink this, I'm going to shrink it by 4. So I have 4 boxes. So this point right here is going to shrink by 4. So instead of it being 4 boxes, it's now going to be 1 box. How do you know that, Miss Ainley? Because you can do 4 boxes It's not letting me write. 4 boxes. Oh, it's not letting me write. I'm just gonna have to say it. It's 4 boxes and then divide it by 4 because I want to shrink it by a scale factor of 4. So it was like this before, right? So this point right here was 4 boxes away. Or you can just multiply pi over 2 times 1/4 because it's a reciprocal, right? So it's the opposite. So 1/2 times 1/4, and you're going to see that it's going to be this number here. So it's not going to be a quarter, but it's going to be an eighth. So pi over 8. Okay. All right. So that's shrunk by a fourth, and you can see it compressed, right? So just be making sure it's compressing. And then finally, to get this actual number, this is not the real one. I'm not going to shift it. What's this, left 4 pi, because this -4 is actually doing something to it. So we're going to take it out. And again, x has to be by itself positive. So we're going to take out, and unfortunately, it's not letting me write anything down. So you're going to have to just listen to me say it. Yeah, it's not letting me do anything. Okay, so taking out -4, if you take out whatever is, oh, there it is, without touching the x, I'm going to take out the -4. So I'm going to have -4 outside. What do I have left inside? I have an x. This plus is going to change to a minus. And then taking out 4 is dividing by 4 is just going to be pi. All right, so again, greatest common factor, if you want to check it, you can just see if you multiply it back in, you get the same thing. So really what this question is asking me to do is move it right pi. So right pi. So I take 0, I'm going to move the 0 point all the way to pi. 0 point all the way to pi. So just be careful when it's not equal to 1 and you have a shift, you must first factor it out for just the shift part, not for the everything else. All right, so we have a cosine graph. Remember, cosine is the one you need to be careful with just because it's not 0, 0, okay? So the very first thing we're going to do is this negative. Negative inside is opposite no matter where you look at it. So you think flip over the x, but it's really flip over the y. And the very cool thing about the cosine, look at this. You see my martini glass right there? And then you see another martini glass right there. So if I flip it over the y, it's going to be the exact same graph, right? So I don't even need to mess with that. Flipping over the y for cosine doesn't change anything because this period keeps repeating. All right, so it doesn't change anything. With sine, it does. All right, so flipping it over doesn't change anything over the y. Next thing I need to do is 4 times. All right, so times 4, so you think stretch, right, by 4, but it's really compressed by 4. So everything is going to shrink by a fourth. All right, so now let's shrink it. All right, so remember, these are the only ones that shrink, right? But we have to be careful where they go. So, because this is cosine, because it's not at 0, 0, when I shrink it this way, it moves from that 1. And I know that when I multiply the 0 here by any number, it's going to stay right there. So it needs to stay right there. So for cosine, remember, we're going to move it here, shrink it, then move it back. So again, I have 4 boxes away. 4 boxes times 1/4 is 1 box. Or you can do pi over 2 multiply times, or you can even do this one actually. Let's do this one. Pi times 1/4 is going to be 1/4. So this line right here should move at 1/4. This is 1/2, so 1/4 will be right here. So when I shrink this to 1 box, you should see it move at 1/4, and that's right. So once you have it shrunk, move it back to where, this is at 1. So let's just move it back. And this is just because IXL is not letting you do too much. If you're doing this on paper, you wouldn't need to do all that. Okay, so that's shrunk by a fourth. And then remember, this is not really the true period. We have to find the true period by taking out, x has to be on its own. So whatever this is has to go outside so that I can see what my true period is. So I'm going to take out -4. Oh, I guess it's not letting me write. It wants me to write with this, with just my mouse. All right, so take out -4. What's left? X. The positive needs to be negative because a negative times a negative will give me this positive. And then 2 divided by 4. So 2 pi divided by 4 simplifies to what? 2 goes into 2 one time and into 4 2 times. So pi over 2. So this is my actual shift. Okay, so remember, this is not your real shift because you haven't taken out this -4. All right, so what happened to my graph? Now I forgot everything I did, so I'm just going to do it again. So flip is not going to do anything. Then we have shrink it by 4, so everything's going to move by a quarter, so 1 box, and then move that back to 1. All right, cool. So actually, let me do that again. We'll move that there, then do it. Now move it back. All right, cool. So that's what my graph is. And now we're going to take my graph and we'll move it right, pi over 2. So here is where I'm at. Pi over 2 is how many boxes? From 0, I'm going to count 1, 2, 3, 4 boxes. So this point needs to move right 4 boxes. Or you can track any point that you want that needs to move pi over 2. So like, for example, half of pi, right? This top one needs to end up over here. So as I move this, I'm tracking that top one. And boom, as soon as it reaches, I'm good. Okay. Additionally, what you could do is move 4 boxes. 1, 2, 3, 4. And you see how it's still that same place. So you can do by boxes or you can do by the actual letter. Okay. So it looks like once you get to 80 something, this is what it's doing. So again, ooh, a little complication, but it doesn't matter. We gonna handle this. We got this. We're gonna start off with sine. Boom, sine. Okay, cool. What are we going to do to it? A half, which means it needs to, inside is a half, which is opposite, which is the reciprocal. So it needs to stretch by 2. So it needs to be twice as long. So instead of this going to pi over 2, it needs to go to pi to pi. So this maximum needs to be at pi. And because it's sine, you remember sine doesn't change. I'm good. That 0 stays at 0, so I'm all right with that. All right, then to get the actual period, remember this is the fake period, right? The fake period. So the real period is you got to take out whatever is in front of the x, which is 1/2. So we're going to take out 1/2 and see what my real period is. If I take out a half, I'm going to have x plus, and then if I take out that half, I'm just going to have the pi. Because again, when you multiply this back in, you get this. So my actual period, my real period is right pi. All right, so I'm at 0. I need to go where? Right. Oh, that's not right. Sorry. Ooh, Miss Ainley about to get this wrong. Opposite, right? X and opposite. So left pi. So this 0 is going to go left pi. All right, then the final thing is, what does this plus 3 do? Move it up. So this is my middle one. That's why I'm sticking to it. So it's going to move from 0 up to 3. Boom, boom, boom. We got this. We can. All right, good. This one's another complicated one. All right, so let's do cosine graph, which is that vertical stretch by 3. And then what does this do? Okay, so let's do the negative first. So negative inside is flip opposite. So I would think x, but flip over y. And remember, cosine looks like the wine glasses on both sides. So if I flip it over y, it stays the same. So I don't have to do that. Then remember, this is 2/3. You take the reciprocal is the opposite, which means 3/2. Put 3/2 in a calculator, it's 1.5. So it needs to stretch by 1.5. So again, remember, because this is cosine, right? We have to move it to 0, stretch it, and move it back, right? So we'll move this back here. But let's stretch it by 1.5. So what does it mean by 1.5? So if it's at 4 boxes, that's 1, because I'm going to stretch this one, right? So 4 boxes is 1. 0.5 of 4 boxes will be another 2. So 1.5 will be a stretch. 1.5. So 1 is 4 boxes, then half of 4 boxes, an additional 2. Now, again, don't forget, because this is cosine, we're going to move it back. So let's put that back there. All right, boom. So we're looking good so far. And remember, this is the fake period. So now we got to do what? We got to factor it out to find out what the real period is by taking out whatever is bothering x. So we take out -2/3. That's going to leave x. It's going to change this sign from a negative to a positive, because a negative times a positive is a negative. And then if we're taking out 2/3 here, we're just left with pi. Again, remember, when you multiply back in, it should give you the same thing as when you're taking it out. So this is left pi. So I'm going to take this and I'm going to move it left pi. Because the only one I can move is this. I'm going to count how many boxes pi is. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to move this 8 boxes left. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to end up 2 on this other side. Boom. All right, so it doesn't matter. All right, so I wanted to do some more with some fractions, so I'm practicing some extra problems. All right, so we're going to start off with sine. Boom, sine. All right, we're going to stretch, vertical stretch by 5. So from 1, it goes to 5. Vertical stretch. Boom. All right, negative inside, opposite of what you think. So inside is x, so it's really flip over y. Okay, so this one does matter because it's sine. This one this maximum needs to come to the other side. So from positive pi over 2, it needs to go to negative pi over 2. Boom, that's my negative. All right, shrink by 1/2 really is opposite, which means double, right? Stretch. Because this is cosine, it's okay, because when I start stretching, you see that 0 stays at 0, so I'm okay with that. All right, so I'm stretching by 2. That means this bottom one is going to multiply this by 2, is going to go to pi, right? So this bottom one goes to pi. Boom. All right, now this is my fake one. So remember, to get my actual shift left how many, I have to take out what's bothering the x. All right, so I take out negative 1/2. Let's see, pen. So I take out negative 1/2. And what do I have left over so I can see what my period is? So here I'm going to have the x. When I take out a negative, that's going to change that sign to a negative. Taking 1/2. So again, you can do this with a calculator. So it's just 1/8. It's what it is. Taking out 1/2 is dividing by 1/2. And you do this with a calculator. I just don't have one on hand, so I'm going to do it by hand. So 1/8, keep, change, flip, and simplify. So the top simplifies right here. This goes in 1 time. This goes in 4 times. Nothing else simplifies. 4 times, sorry, 1 times 1 is 1. 4 times 1 is 4. So this real number is pi over 4. All right, now that I have my actual period, this means I should go where? Right 1/4, right? So now the only one I can move is this. There's no 1/4, there's 1/2. So let me figure out how do I get a fourth? Well, half of a half is a fourth. So in other words, like let's say this was $1. This will be half a dollar, and half of $1, which is half of 50 cents, will be a quarter. So half of this distance here, which is half of 4 boxes, is 2 boxes. So I'm going to move this right 2 boxes, right 2 boxes. And I'm good because there's nothing else that I need to do out there. All right, so we got a sine one, so we're going to go to sine. Boom. All right, vertical stretch by 2. So vertical stretch by 2. All right, horizontal shrink by half. So sine, remember, we don't need to move because when I shrink it by half, so this is 3 boxes, going to go to 1.5 boxes. You see, it actually shrinks, right? So I don't even need to worry about it because the 0 stays at 0. So cosine is the only one you got to move and move back. All right, so shrink. All right, now I got to take out, to find out this period, I got to take out this 2, right? So I'm going to take my 2 outside, so it's going to leave an x. Negative, because it's going to multiply out. And then I got 1/3 divided by 2. And you're just going to simply put that in a calculator. So 1/3 divided by 2. All right, it's going to be 1/6. So this is going to be pi over 6. So you just got to figure out how many boxes is pi over 6. So let's figure that out. So we got pi. We'll do pi. All right, so here we go. We've got 0 here and pi here, which pi is going to be 6, like 6 sixes, right? So we got to split this up to where we have 6. 1, 2, 3, 4, 5, 6, because 6 sixes will be the 6, right? All right, so now, and I need how many? I need 1/6, so I only need the distance from here to here. Okay, cool. All right, so the distance to pi is 1, 2, 3, 4, 5, 6. 6 boxes. Oh, that was easy. So what's 1/6 of 6 boxes? Going to be 1 box. So 1 box is what we are doing. And what are we doing exactly? Because I forgot just that quick. Sometimes when you explain, you just forget what you're doing. All right, I'm moving right 1 box. So moving right 1 box. That's what I just did. Right 1 box. And then the last step is to move up 5 boxes. So this is the one that moves up 5 boxes. That's going to bring here. So up 5 boxes. All right. And again, it's okay if you make some mistakes. I make them all the time. It's fine. Let's just practice until we get it right.